Hi and welcome back. So in the past video, we started, in the past couple of videos I guess, we started talking about valence electrons and we did a couple of examples where we counted up, or we figured out the number of valence electrons that a few different elements had. And what we're going to do in this video is we're essentially just going to do the same thing, and we're going to see if we can find any patterns of how many valence electrons some elements might have based on where they are on the periodic table. So anyway, let's get started. And in this video, I am going to use the nearest previous noble gas electron configuration because it makes it much easier to talk about valence electrons. And also, right now, we are just talking about valence electrons that are in, if you remember, this is our S block, and this is our P block. So we are just going to be talking about valence electrons in the S and the P blocks. When we get into the D block, talking about valence electrons gets a little bit more complicated. And we will definitely talk about that. We will definitely tackle that. But we are going to concentrate on the S and P blocks before we get into the D block here. So anyway, I'm going to clear that off. Let's do lithium. So lithium is right here. And we're going to use, lithium. And we're going to use our nearest previous noble gas electron configuration. So our nearest previous is going to be helium. And then on top of helium, what is lithium's electron configuration? And I'll just number our periods again. 4, 5, 6, 7. So on top of helium, all that lithium has, the only extra electrons that lithium has, are our 2s1. We've only got one extra electron on top of helium, right? And it goes into our 2s orbital. So therefore, how many valence electrons, and remember that all of helium's electrons, they're all 1s electrons, right? So how many valence electrons does lithium have? Well, it just has, right over here, it's got one, right? It's got one valence electron. Let's do another one. Let's do, right below it, let's do sodium. So sodium is right here. It's element number 11. And I'll actually switch colors. So sodium. And we're using our nearest previous noble gas, which in sodium's case is going to be neon over here. So we're going to say that sodium's electron configuration is the same as neon. And then on top of that, what do we have on top of neon? Well, we have 3s1, right? And in neon's electron configuration, are there any third level electrons? And no, there aren't. What we have in neon's electron configuration, I'll write it out here. Neon's electron configuration is 1s2, 2s2, 2p6, right? There's no third level electrons. So also for sodium here, for sodium, because sodium doesn't have any third level electrons aside from this one, sodium is also going to have one valence electron. So that's kind of interesting. Right on top of each other, lithium had one valence electron, sodium had one valence electron. Let's try potassium. And actually, I'm going to erase this right here, this expansion I did. So let's try, didn't want to erase all of that. So one valence electron. So let's try potassium. So potassium is going to be right here in the periodic table, right below sodium. So potassium. And what's our nearest previous noble gas? It's going to be argon, right, for potassium. So potassium is going to have argon's electron configuration. And then potassium is going to, the only extra electron we're going to have on top of argon is going to be 4s1, right? So therefore, does argon have any fourth level electrons? You can do the electron configuration for argon yourself and see that no, argon doesn't have any fourth level electrons. So potassium also is going to have one valence electron. And hopefully you can see that if we kept doing this, if we kept going down this column, we would find, so I'll change colors so I can have a good color to do this, we would find that all of the elements in this column, all of these elements, and hydrogen included, even though I did look it up, and hydrogen is not considered one. If you remember the name of this group of elements on the periodic table, it was the alkali metals. And hydrogen, I actually found out, is not included in the alkali metals, but we are going to include hydrogen in this grouping because we can say that all of these elements in this column, they're all going to have one valence electron. Let's see if another column on the periodic table, if we can find a similar tendency based on these columns. So actually, I'm going to erase all of this stuff. Actually, make my eraser a bit bigger. There we go. So I'll just erase all of that. Okay, let's go ahead and let's choose, I don't know. Actually, let's choose oxygen's column. So we're first going to do the electron configuration for oxygen, and then we're just going to do the electron configurations for all the elements below oxygen in the same column. So if we were looking at oxygen, what's the nearest previous noble gas to oxygen? Well, it's going to be helium, right? So helium is the nearest previous noble gas. And then on top of helium, what electrons does oxygen have? Well, we're going to have our 2s2 electrons, and then we're going to have 2p4 electrons. And helium, as we talked about in the last example where we were dealing with our alkali metals column, helium doesn't have any second level electrons, right? The only electrons that helium has are in the 1s shell, right? So therefore, these are all of oxygen's valence electrons, the 2s2 and the 2p4 electrons. So oxygen is going to have six valence electrons because we add up 2 plus 4 is 6 valence electrons. Let's do, I think I did this in the last video, but let's do it again. Let's do sulfur. So sulfur is right below oxygen. So sulfur. What's the nearest previous noble gas? Well, it's going to be neon. Neon, right, is the nearest previous noble gas. And then on top of neon's electron configuration, what electrons does sulfur have? Well, it's going to have 3s2, 3p4, right? And we can see neon doesn't have any third level electrons. We can see again, sulfur is also going to have 6 valence electrons. Let's do one more. Let's do selenium. So selenium, choose a good color. So selenium, right there, Se. So what's the nearest previous noble gas from selenium? Well, it's going to be argon. Argon, right? So argon, Ar. And on top of argon, what is selenium's electron configuration? And you can maybe see that this is where it starts to get a little bit interesting, right? Because selenium's electron configuration on top of argon is going to be 4s2. And then what happens? Well, we've got our third level electrons, 3d10. So we don't have So we can say that we've got 4s2, 3d10, so we had 10 of these electrons that actually backfilled into, you could say, a non-valence energy shell. And then after we fill up our 3d10, then what do we have? Well, again, we've got our 4p4 electrons, right? We've got 4p electrons, and we've got 4 electrons in there. So now you might be wondering a little bit, well, do I include these 3d level electrons in our valence electrons? And no, you don't, because these are, you could imagine, one energy level back from where they're available to react. And maybe in the next video or maybe not in the next video, but in a future video, I'll maybe draw another depiction of the atom and give you a bit of an intuition behind why these electrons might backfill an energy level, I guess. But the important thing to realize here is that the number of valence electrons is defined by the number or the number of electrons with this highest period number. So these 3d10 electrons here, at least for our S and P blocks, but selenium is in our P block. At least when we're in the S and P blocks, these 3d10 electrons, they don't count at all. So selenium is also going to have 6 valence electrons. So now you might see that we've got a similar pattern. We've got a similar pattern of being able to see valence electrons. And what we're going to find out is that everything in this row right here is going to have 6 valence electrons. So anyway, I'm actually out of time in this video. In the next video, we're going to start talking about maybe what this means for the reactivity of these different elements, and the fact that these elements have got 1 valence electron, and they all have 1 valence electron, and that these all have 6 valence electrons. And maybe we'll start to also fill up some of the other columns in the S and P block. And actually, it might be a good idea for you to, before you watch the next video, maybe just try to figure out, do on your own, see what the number of valence electrons would be for all of the elements maybe in this group. This is the boron family, I guess, the boron group of elements. And see if you find a similar pattern of how many valence electrons all of these elements should have. And do the same for maybe the alkali earth metals, for this family of elements over here, and see if you find a recurring pattern. Because in the next video, I'm probably not going to go through all of these examples of figuring out all the valence electrons for each of these families. I'll probably just tell you the number of valence electrons they have. So if you want, it might be a good exercise to just try to figure out how many valence electrons maybe all of the elements in this family have, and then all of the elements in this family, and then maybe all of the elements in the carbon family. So anyway, with that, I'm actually going to end the video, and I will see you soon in a future video. Thanks for watching.